I'm Nova.
I'm Alloy, and this is AgentStack Daily. Today starts with OpenClaw v 2026.5.27 and v 2026.5.26, because the newest release closes a real gap in the local agent stack, content boundaries, no-auth exposure checks, Codex app server recovery, provider catalogs, embedding providers, BLLM thinking parameters, Claude OAuth overlays, durable channel delivery, package checks, and CI-proof paths.
Codex 0.134 also landed with a more useful local CLI shape, conversation history search, profile-first configuration, better MCP setup, streamable HTTP OAuth, read-only MCP concurrency, connector schema preservation, and richer hook and extension context.
Claude Code's latest line adds review fix mode, skill tool restrictions, skill reload hooks, message display hooks, marketplace suggestions, fallback model continuity, update and doctor visibility, stricter subagent MCP policy handling, OAuth gateway credential fixes, and a lot of background session repair work.
The useful thing about this episode is that the release block is not isolated. The outside stories are the same stack becoming more practical: governed MCP gateways, local code graph tools, shared agent memory, mobile control bridges, local model routers, and DGX Spark plus LM Studio as a private model server.
So the story is not abstract agent optimism. It is the machinery around agents getting stricter, more local, and more inspectable. The more an agent can do, the more the gateway has to know what authority it is handing out, what code the model is seeing, what state multiple agents share, and which model endpoint actually fits the job.
That is why OpenClaw's security line matters. Group prompt text staying out of the system prompt is not a cosmetic refactor. It reduces the chance that ordinary channel content becomes privileged instruction. Repeated .hostnames getting normalized is the same kind of defensive move: reject weird input forms before they become policy bypasses.
The side-effecting command wrapper blocks and unsafe node runtime environment override blocks are also important. Agent stacks tend to route through wrappers, helpers, runtime launchers, and command adapters. If those wrappers can quietly mutate the environment or escape the expected command boundary, the permission model becomes theater. This release is trying to close those boring but dangerous gaps.
No-auth tailscale exposure rejection is the one I would underline. Local first does not mean private by magic. A machine can be on a private network and still expose a no-auth service in a way that is too broad for an agent gateway. Rejecting that shape before it becomes a live surface is exactly the kind of check a local control plane should have.
Admin-only node and device role approvals belong in the same bucket. Once an agent can route work across nodes, devices, channels, and helpers, the question is not only whether the model is smart. The question is who is allowed to approve a role change, a device path, or a node capability. That has to be explicit.
The practical recommendation is simple: upgrade OpenClaw, then verify one reply path, one Codex app server run, one provider catalog path, and one exposure check. Do not treat the release as installed just because the process starts. The value is in the boundaries and recovery paths actually behaving under a real task.
That workflow gives builders a clean use case for the upgrade: build one safe reply, build one Codex app server workflow, build one provider routing workflow, and build one exposure check workflow before trusting the release in a daily agent task. And with that foundation, let's move through the release details and the 6 infrastructure stories that make this episode useful.
OpenClaw the 27th of May, 2026, Codex 0.134, and the latest Claude Code 2.1 line close the release gap. The exact spoken labels are shorter than the package strings, but the concrete changes are dense enough to matter. OpenClaw's current release is the deepest part: gateway hardening, app server resilience, provider expansion, metadata caching, and delivery reliability all moved at once.
Start with content boundaries. Group prompt text no longer gets treated like system prompt material. That sounds obvious, but chat surfaces, Discord channels, web chat sessions, voice transcripts, and tool observations can all arrive as text. A local agent host has to preserve the difference between user content, channel metadata, tool output, and privileged instruction.
Hostname normalization is another small detail with large security weight. Repeated .hostnames can create surprising interpretations across parsers, proxies, and allow lists. Normalizing them before policy decisions means the gateway evaluates the same host shape that downstream tools are likely to use.
The command wrapper work is about side effects. A wrapper that looks like a harmless route into a command can become an authority escalation if it changes the runtime, environment, or command target in a way the permission layer did not account for. Blocking side-affecting wrapper shapes makes the command boundary less dependent on trust in helper code.
The unsafe node runtime environment override block fits that same pattern. Node tooling is everywhere in agent stacks, CLIs, plugin hosts, build scripts, app servers, package managers. If runtime environment overrides can redirect execution, inject loaders, or change module resolution, the model may not be doing the dangerous part, the launch environment is.
The no-auth tailscale exposure rejection is the network version. Tailscale can make local machines conveniently reachable, but convenience is not authentication. If a service is reachable without auth, the gateway should not pretend the private network label alone is enough. This release makes that stance clearer.
Then there is the Codex app server work. Runtime models resolve first, workspace memory routes through tools, shared app server clients survive startup and spawned helper failures, hook relay generations survive restarts, and false runtime live switches are avoided. Those are reliability changes for the moments that usually make coding agents feel flaky.
A shared app server client surviving startup and helper failure is especially practical. Coding sessions often launch helpers, subagents, local app servers, previews, and tool relays. If one helper fails and poisons the shared client, the whole session can become unstable. Recovery needs to be a first-class behavior, not a lucky restart.
Gateway hot paths also get less wasteful. Session reads, plugin metadata fingerprints, auth environment snapshots, auto-enabled plugin config, tool search catalogs, and stable metadata caches reduce repeated rediscovery. A gateway that keeps rediscovering the same metadata burns time and creates more chances for stale state.
Provider coverage expands in useful directions. Core OpenAI-compatible embedding providers become more first-class. Deep infra model browsing becomes credential-aware. Pixverse video generation and region selection get surfaced. DLLM thinking parameters become configurable. Claude CLI OAuth overlays support PI auth profiles. Direct Anthropic model IDs are accepted without unnecessary alias gymnastics.
That provider list matters because an agent stack is rarely one model endpoint now. It has chat models, embedding models, image and video providers, local OpenAI-compatible servers, cloud fallbacks, and sometimes browser-backed auth. The provider layer has to describe capability, credentials, region, and special parameters instead of acting like every endpoint is interchangeable.
Codex 0.134 is a practical CLI release. Local conversation history search means older work can be found by content with previews. That sounds small until you are trying to recover why a change happened, which branch was used, or what the agent already learned before context compaction.
Profile-first configuration is also a good move. A profile can bundle sandbox behavior, permissions, model choices, and local expectations. That is cleaner than a pile of one-off flags that are easy to forget and hard to audit. For daily use, profiles become the difference between a repeatable agent mode and a remembered command line.
MCP setup in Codex gets more serious too, per server environment targeting and OAuth options for streamable HTTP servers. Per server environment targeting matters because one MCP server might need a project variable, another might need a safer read-only profile, and a third might be remote. Treating them as one environment is sloppy.
Connector schema preservation is one of those changes that only sounds dull until a tool breaks. Local references and definitions inside a schema can carry meaning. If they get flattened badly, compacted wrong, or exposed without structure, the model may call a connector with the wrong assumptions. Preserving schema shape makes tool use less guessy.
Read-only MCP concurrency is a real productivity feature. If a server advertises the right hint, Codex can run read-only tools concurrently instead of serializing harmless inspections. That is exactly where concurrency belongs: querying state, searching metadata, reading docs, or inspecting context without mutating anything.
Claude Code's latest line has a different emphasis. Code review fix mode lets review and repair sit closer together. The simplify command can invoke that fix path. Skills and / commands can remove tools with disallowed tools. Reloading skills becomes explicit, and session start hooks can reload skills and set titles.
Disallowed tools inside skills and / commands are particularly important. A skill should be able to say not only what it is good at, but what authority it should not have. A documentation skill does not need destructive shell operations. A review command may need file reads but not publishing. Tool removal is a boundary feature, not just a convenience.
Message display hooks are another sign that coding agents are becoming programmable environments. What the human sees at review time matters. A hook that changes how messages are displayed can support better status, safer summaries, or clearer review surfaces, as long as it does not hide evidence.
Fallback model continuity is also worth watching. If the primary model becomes unavailable and the configured fallback takes over for the rest of the session, the workflow keeps moving. But this also means teams should decide what fallback actually means. A fallback should be cheaper or more available, but still safe for the permission profile it inherits.
The follow-up Claude Code reliability work is heavy on background sessions, remote MCP proxy fixes, stricter sub-agent MCP policy handling, OAuth gateway credential fixes, and macOS background agent permission continuity. That is the daily agent layer, less drama when the session moves into the background, crosses MCP boundaries, or survives an update.
Hermes stays on its existing release, so it belongs in compatibility watch rather than the release block. The action is OpenClaw plus Codex plus Claude code, upgrade them together, then test a gateway reply, Codex history search, profile-based config, one streamable HTTP MCP server, one Claude skill with restricted tools, one code review fix run, and one background session across an upgrade.
The reason to do those checks is not process worship. These releases are about authority and recovery. If the gateway rejects unsafe exposure, the CLI remembers work, MCP tools preserve schema, and background sessions survive routine turbulence, then the local agent stack starts to feel like infrastructure instead of a pile of demos.
The useful builder test is to make each new capability prove one use case, a safer command path, recoverable history search, a restricted skill setup, and a background session that survives a normal upgrade. MCP gateway projects are turning tool access into governed infrastructure. IBM ContextForge and Jarvis Registry are both pushing a similar idea. An AgentStack should not accumulate random MCP servers, REST wrappers, private endpoints, and A2A agents with no common control plane.
ContextForge is a Python gateway, registry, and proxy for MCP, A2A, REST, and gRPC. It gives the stack a place for governance, discovery, observability, plugins, OpenTelemetry traces, Redis-backed federation, and Kubernetes deployment. That is a very different shape from putting a dozen server entries into a coding assistant config and hoping nobody forgets which one can mutate production.
The latest ContextForge release completes a React admin UI rewrite, improves database migrations through Alembic, strengthens OAuth flows, and improves multi-replica behavior. Those release details are not glamorous, but they are what move a gateway from a local experiment towards something a team could operate.
A registry is useful only if operators can see and manage it. The admin UI matters because discovery and policy need a human surface. Database migrations matter because tool catalogs, identities, scopes, and audit records change over time. OAuth flows matter because an agent gateway without identity is just a fancy proxy. Multi-replica behavior matters because one gateway process should not be a single fragile object in a larger stack.
Jarvis Registry comes at the same problem with a workflow runtime angle. It is an MCP and A2A gateway with OAuth and OIDC identity, ACLs, semantic discovery, request logging, Prometheus metrics, and workflow orchestration. The latest release adds a workflow execution engine with MongoDB-backed run state, A2A and MCP step dispatch, pause, resume, cancel, retry APIs, persisted workflow endpoints, refresh token rotation, scope negotiation, and A2A discovery inside search and gateway tools.
That set of features is important because tool access and workflow execution are starting to merge. An agent does not only ask for a tool once. It may discover a capability, start a workflow, wait for a result, pause for a human decision, resume with new state, cancel a bad path, or retry a failed step. If every one of those behaviors is hidden inside a chat transcript, the stack is hard to govern.
The technical distinction is gateway versus registry versus proxy versus workflow engine. A proxy forwards calls. A registry describes what exists. A gateway applies identity, policy, routing, observability, and sometimes transformation. A workflow engine carries run state across steps. In practice, real projects blur those roles, but the stack needs all four capabilities somewhere.
MCP and A2A federation make the need sharper. MCP gives models structured tools and resources. A2A points at agents talking to agents. REST and gRPC are already the shape of many internal systems. A gateway that can translate, register, and police those surfaces becomes the choke point where authority can be understood.
OAuth and OIDC are not optional here. Once agents can call internal tools, identity cannot be just a local config file. You want access tokens, scopes, refresh token rotation, service identity, user identity, and a trace of which agent asked for which capability. Otherwise, a failed or compromised agent session becomes very difficult to explain.
ACLS are the next layer. A read-only documentation tool, a customer data search tool, a deploy tool, and a workflow cancel endpoint should not share the same exposure rules. The gateway needs to decide what appears in discovery before the model ever sees it. Disabled tools should disappear from the assistant's available surface, not sit there as tempting forbidden fruit.
OpenTelemetry and Prometheus are what make the calls debuggable. When an agent invokes a tool, you want traces, spans, latency, status, caller identity, and policy decisions. Without that, postmortems become screenshots and vibes. With it, a tool call is part of the system record.
The practical evaluation is straightforward. Put one harmless read-only MCP server behind ContextForge or Jarvis registry. Enforce identity. Inspect the discovery output. Call one tool. Trace it. Disable it. Confirm the coding assistant no longer sees it. Then add one mock A2A agent and test pause, resume, cancel, and retry semantics.
That is the moment when the project stops being a connector demo and starts becoming infrastructure. If discovery, identity, tracing, and disabled tool behavior all work, the gateway is carrying real control plane weight. If those pieces are vague, the gateway may just be a prettier config file.
The bigger point is that MCP adoption creates tool sprawl unless something governs it. ContextForge and Jarvis Registry are interesting because they are trying to make the tool layer visible, federated, policy-aware, and observable. For agent builders, that is not a side project. It is the difference between controlled capability and accidental authority.
Local code graph tools are replacing blind grep with agent-readable structure. Codex and Roam code are useful because they do not just promise better search, they give coding agents a more structured view of symbols, calls, dependencies, evidence, and risk before an edit.
Codex is a Rust local code intelligence MCP server and CLI for Claude, Gemini, and Codex. It exposes code search, symbol search, semantic search, caller and callee queries, and document search through a local index. The latest release improves method call resolution in exactly the places where naive search tends to mislead agents.
Static calls now disambiguate by receiver type. Instance calls infer receiver types from caller parameters. PHP gets inheritance-aware resolution. The breaking change is that wrong class same-name methods are now left unresolved instead of being confidently wrong. That is a healthy failure mode.
Unresolved is safer than falsely resolved. If an agent asks who calls a method and the code graph points at the wrong same-name method in another class, the model can build a whole edit plan on a false dependency. Returning unresolved forces the agent to inspect more evidence instead of pretending precision exists.
The mechanism is symbol graph work. A symbol is not just a string. It has a language, a file, a scope, a class or module, a signature, references, callers, callees, and sometimes inheritance relationships. Static method resolution needs to know the receiver type. Instance method resolution has to infer what object the call is probably using. PHP inheritance makes this more complicated because same-name methods can appear across parent and child classes.
Codana also uses local indexing, including Tantivy fields, so the model is not crawling the repo from scratch every time. That is the kind of local tool a coding agent should query before it edits a shared symbol. grep can find text. A code graph can answer a more important question: which definition is this, and what depends on it?
Rome code is more like a local preflight and evidence layer. It builds a SQLite code graph, exposes a large CLI and MCP surface, supports policy modes, scrubs secrets from MCP responses, creates change evidence packets, produces code graph attestations, supports PR replay, calculates blast radius, identifies affected tests, scores complexity, and works in air-gapped settings.
That is a different but complementary promise. Codana helps the agent see code structure. Rome code helps the agent prove what it inspected and what the risk surface looks like before and after a change. In a serious workflow, both types of tool are more useful than another bigger context dump.
The evidence idea is worth pausing on. A human reviewer wants to know what authority existed, what context was read, what changed, what could break, what policy applied, which checks ran, and who accepted the risk. If an agent-assisted edit cannot answer those questions, review becomes a trust exercise instead of an engineering review.
A local SQLite graph also has the right privacy shape. The repo can be indexed locally. Query results can be filtered. Secrets can be scrubbed. The model gets a structured answer instead of being handed a giant pile of files. That gives the stack more context without spraying the entire codebase into every prompt.
Blast radius checks are where this gets practical. Before editing a risky function, the agent should ask who calls it, what tests might cover it, which modules depend on it, whether the area has high complexity, and what conventions nearby code follows. That changes the edit plan. A small refactor with 3 callers is different from a helper buried under 5 services and no tests.
Affected test discovery is also an antidote to lazy verification. An agent often runs either everything, which may be slow, or the closest obvious test, which may miss the real dependency. A graph-backed tool can suggest a narrower but better test set, then the transcript of the work can say why those checks were chosen.
The action item is clear. Test Codana on one real repo by indexing it and asking for callers, callees, and semantic search before a small edit. Then test Rome code with health and preflight against one risky symbol. Compare the agent's plan before and after the code graph evidence. If the plan does not change, either the tool is not integrated well or the task was too trivial.
For AgentStack builders, this is one of the most important open-source lanes. Models are getting better, but codebases are still structured systems. A coding agent that sees an accurate call graph can be less dramatic than a larger model guessing from search results. Local code graph tools make the repo legible before the model starts editing.
Shared local memory and task state are becoming the missing layer between parallel agents. The Agent Guild project is interesting because it treats memory as shared project infrastructure, not as a private diary for one chat session.
The Agent Guild is a single Go binary with a first-class MCP server, embedded SQLite, BM25+ semantic retrieval, local-only state, and atomic task claims. Claude Code, Codex, Cursor, or another MCP client can read the same project context, claim work, record outcomes, and leave handoffs.
The latest release tightens local file permissions on the Guild directory and SQLite sidecars, validates catalog taxonomy upfront, makes concurrent quest event ordering deterministic, adds stable secondary sorts, and improves install path resilience. That is exactly the kind of release detail that says the project is thinking about multi-agent reality.
File permissions matter because local memory is still sensitive. It may contain decisions, summaries, task state, links to files, failure notes, and maybe snippets of private context. A shared agent store should not be world-readable just because it is local. Local only is a good privacy posture only when local access is also controlled.
Deterministic event ordering matters because parallel agents create race conditions. If two agents claim tasks, write updates, or append events at the same time, the store has to produce a stable timeline. Otherwise, the handoff record becomes another source of confusion.
Atomic task claims are the central feature. The collision problem is not only memory. It is two agents deciding they own the same change, both editing nearby files, both running partial checks, and both summarizing as if they had exclusive context. A claim gives the system a small lock around intent.
BM25 plus semantic retrieval is a sensible combination. Keyword search is good for exact file names, commands, terms, and issue IDs. Semantic search is good for remembered decisions and fuzzy descriptions. A local project memory store needs both, because humans and agents remember work in different shapes.
The important distinction is shared state versus prompt stuffing. Dumping old transcripts into every new session makes context large and blurry. A shared local state layer can expose only the project summary, active tasks, decisions, blockers, and handoff notes that matter now. That is more useful and less noisy.
Swarm Vault and Awareness Local point in the same direction from knowledge graph and agent memory angles. The specific projects differ, but the trend is clear. Memory is moving out of a single model context window and into local stores that several agent surfaces can query.
The risk is authority creep. If every agent can write anything into shared memory, the store can fill with stale decisions, hallucinated facts, or conflicting task claims. The first governance rule should be boring: define what agents are allowed to write. Project summary, active task, decision record, blocker, outcome, and handoff are good starting categories.
The test should be small. Create one project state store. Write one active task and one decision record. Have two different clients read it. Let one claim the task. Make sure the other sees the claim before it starts work. Then add a handoff note and check that a new session can recover the context without reading a huge transcript.
That is the point where memory becomes operational. It is not just a nicer recall feature. It is a coordination layer. Several agents can avoid rediscovering, colliding, and forgetting the same thing. For local agent stacks, that may be as important as a new model release.
Mobile control bridges are attacking the babysitting problem without moving execution off the local machine. Lucarn is the clean example in this slate, a Rust resident process for supervising local coding agents through Telegram or WeChat without hooks, skills, MCP, or project changes.
It watches local Claude, Codex, Gemini, Copilot, and Pi sessions. It sends notifications for approvals, clarifying questions, failures, and progress. It lets a user resume or act from an existing messaging channel while the agent keeps running on the local computer.
The latest release downgrades stale watch session targets, which sounds tiny but reveals the product shape. A watcher has to know whether a session target is fresh. If it routes an approval to the wrong or stale session, mobile control becomes dangerous. Correct session targeting is the whole feature.
The bigger architectural point is that Lucarn separates the execution boundary from the attention boundary. The local machine still owns files, credentials, tools, browser profiles, and build outputs. The phone becomes the surface for the 30-second human moment: approve, clarify, redirect, stop, or acknowledge.
That is different from hosted remote coding agents. Hosted agents move execution away from the local machine. That can be useful, especially for clean public tasks, but it changes where secrets, dependencies, and file authority live. A mobile bridge leaves execution local and moves only the decision point.
There is a real use case here. Long-running local agent work often stalls at exactly the wrong time, a permission prompt, a clarification, a failed test, a question about which branch to use, or a risky command that needs human approval. If the human left the desk, the whole run waits. A bridge can turn that stall into a quick phone reply.
The evaluation should focus on routing correctness, not novelty. Does the notification arrive at the right decision point? Does replying in the messaging channel return to the correct workspace and session? Does the bridge quote enough context to make the decision safe? Does it avoid adding a broad new authority surface?
The no hooks and no MCP design is interesting because it reduces integration burden. Lucan is not asking every project to add a skill, server, or callback. It watches existing sessions. That can make adoption easier, but it also means the watcher has to be very careful about matching observed events to the right session state.
Messaging channels create their own risks. A phone approval should not become a vague remote shell. The bridge should expose narrow actions, session context, and clear prompts. It should not turn a chat app into an unbounded command interface unless the user explicitly configured that authority.
The practical test is one low-risk local agent task. Start a Codex or Claude session that will hit a harmless approval. Step away. Confirm the message arrives. Reply. Confirm the local session resumes in the correct workspace. Then test a stale session and a failure path. If any message routes ambiguously, do not trust it for real work yet.
The larger trend is useful. The best agent run is often local and boring until it needs a human for 30 seconds. Mobile control bridges are trying to make that 30 seconds happen anywhere without pretending the whole job belongs in the cloud.
Local model routers are getting hardware aware instead of treating every model endpoint as the same. Smarter Router is an OpenAI compatible router for Ollama, llama.cpp, and OpenAI style endpoints. It profiles models, estimates VRAM, tracks capability metadata, supports semantic caching, and chooses models based on task and local hardware.
The latest release adds dynamic model metadata extraction, Gemma 4 detection heuristics, mixture of experts-aware VRAM estimation, and automatic capability detection from Ollama's API show endpoint. That is a good release because local model routing fails when the router only knows endpoint names.
A router needs to understand capabilities. Does the model handle tool calls? Does it support vision? How long is the context window? Is it good enough for code? Does it expose embeddings? Does it need a thinking parameter? Is it a dense model or a mixture of experts model where active parameters affect memory differently?
VRAM estimation is not a luxury for local AI. A request that fits on paper can crash, swap, or crawl if the router guesses wrong. Quantization, context length, batch size, active experts, and backend behavior all change memory pressure. Hardware-aware routing is the difference between local AI feeling automatic and local AI feeling like a manual checklist.
Semantic caching also fits this layer. Some local tasks repeat, summarizing similar logs, classifying routine notes, answering repeated documentation questions, or generating predictable metadata. A cache can avoid wasting local GPU time or paid fallback calls when the answer shape is stable enough.
This lines up with OpenClaw's release because the provider layer is also becoming more capability aware. Core OpenAI compatible embedding providers, deep infra catalog browsing, VLLM thinking parameters, and better provider and model handling all point in the same direction. The stack needs to know what each endpoint can actually do.
Embeddings are a good example. An embedding endpoint is not a chat endpoint, and it should not be routed like one. A local code graph, memory store, or search index may need embeddings from a cheap local model, while a complex code review needs a stronger chat model. Treating both as generic model calls is wasteful.
Thinking parameter propagation for VLLM is another example. Some serving stacks expose reasoning or thinking controls. If the router strips or ignores those parameters, the model may run in the wrong mode. A router that preserves meaningful provider knobs gives the higher-level agent a better chance of using the endpoint correctly.
Ollama and llama.cpp backends also differ from cloud endpoints. Local model names may be aliases. Metadata can be incomplete. Capabilities may need detection. The router has to inspect, profile, and sometimes infer. That is why automatic capability detection from Ollama is more than a convenience feature.
The practical evaluation is to put one router in front of a local model library. List detected capabilities. Route embeddings separately from chat. Compare a small local model, a larger local model, and a cloud fallback on the same low-risk coding or summarization task. Watch latency, quality, memory use, and failure behavior.
The recommendation is not that smarter router wins the whole category. The recommendation is that local stacks need this category. Once you have more than one local model, manual model picking becomes a tax on every task. Hardware-aware routers make the machine part of the stack instead of a guessing game.
Local AI stops feeling local when every request begins with the same question: which model should I use? The router layer is the first step toward making that decision explicit, inspectable, and eventually boring.
DGX Spark plus LM Studio shows the local AI server pattern getting more polished. NVIDIA's LM Studio on DGX Spark guide is a concrete serving pattern. Deploy LM Studio on a Spark device, run models such as Nematron 3 Nano Omni locally with GPU acceleration, and use that model from a laptop.
The optional LM link path creates an encrypted link so Spark-hosted models appear remote local to another machine without relying on same LAN assumptions or opening a public service. That is the interesting part. The device is local infrastructure, but the client experience can be more flexible than sitting directly at the box.
DGX Spark in this pattern is not just a fast desktop. It becomes a private model appliance, local enough to keep inference close, service-shaped enough that laptops and agent gateways can use it, and isolated enough that it can be treated as a boundary.
That boundary matters. A coding laptop may have the repo, credentials, editor, and agent session. A model appliance may have GPU capacity and local model serving. The clean design is to expose only the model endpoint needed, keep client credentials on the client side when possible, and avoid turning the model server into a general-purpose remote workstation.
LM Studio is useful here because it gives a familiar local serving surface. A local OpenAI-compatible client can point at a server, a router can sit in front of it, and an agent gateway can treat it as one provider among others. That makes the hardware easier to integrate into the rest of the stack.
This complements Ollama, DLLM, Llama.cpp, and provider routers rather than replacing them. Different local stacks optimize for different model formats, performance targets, deployment styles, and control surfaces. The important change is that local serving is becoming an infrastructure pattern, not a hobby script.
The privacy angle is practical. If the model endpoint stays private and the data does not leave the local boundary, a builder can try workflows that would be uncomfortable with a public cloud model. Summarizing internal logs, indexing private code, testing agent memories, or running a local assistant over sensitive notes all become easier to reason about.
Performance still has to be measured. A desk-side model server is only useful if latency, context capacity, throughput, and reliability fit the job. The right comparison is not a benchmark brag. It is one local route versus one subscribed cloud model on the same daily task, code explanation, log triage, transcript cleanup, or retrieval-augmented summarization.
The encrypted link pattern also changes travel and laptop workflows. A user can keep the heavy inference box in one place and reach it from another machine without publishing a broad service. That does not remove the need for authentication and network hygiene, but it makes the private appliance model more realistic.
For AgentStack, the significance is how this connects back to the release block. OpenClaw is improving OpenAI-compatible providers, embedding providers, model catalogs, and VLLM parameters. Local routers are profiling hardware and model capabilities. DGX Spark plus LM Studio gives the physical serving pattern. These are pieces of the same local model layer.
The practical setup test is narrow. Expose one local model endpoint from the appliance, call it from the laptop, measure latency and context behavior, route a simple task through the same interface the AgentStack uses, and compare it with a cloud model that costs a subscription slot. Then decide which jobs deserve local inference.
The interesting hardware story is not owning a fast box. It is having a private model service that the rest of the agent stack can address cleanly.
The EP058Q is concrete. Upgrade OpenClaw for content boundaries, provider coverage, Codex app server resilience, gateway hotpath cleanup, no auth exposure rejection, and safer command and runtime boundaries.
Upgrade Codex for local history search, profiles, MCP setup, streamable HTTP OAuth, schema preservation, richer hook and extension context, and read-only tool concurrency. Upgrade Claude code for review fixes, tool-restricted skills, skill reloads, message display hooks, fallback models, update visibility, stricter subagent MCP policy, and background session repairs.
Then pick one infrastructure experiment. Put a read-only tool behind a governed MCP gateway. Index a repo with a local code graph before editing. Create a shared local task store and have two agents read the same state. Test a mobile bridge on a harmless approval. Put a router in front of local models. Or treat a DGX Spark and LM Studio setup as a private model appliance.
The common thread is practical control, but the details are the point: governed tools, accurate code structure, shared state, correct mobile routing, capability-aware models, and private local serving. More agent capability only helps if the stack can decide what the agent is allowed to do, what it actually knows, where state lives, and which model should answer.
For source links and episode notes, visit Toby on fitnesstech.com.
That is AgentStack Daily. We'll be back soon.
I'm Nova.